Hi, this is Math 1340, and this video is going to be over Chapter 8.1. We're going to look at systems of equations with two variables throughout this chapter, and we'll be doing them in different ways. So first, when we are dealing with system of equations and we have two variables, you need two equations to solve it. And if we are looking at linear equations, then the solution you're going to end up finding is one of three possibilities. The first one is that you got two lines and they intersect, and that common point is that solution. And we call that a consistent system. And it only has that one solution, and again, it's where the two cross. The other one is if those two equations actually are the same equations, just in different forms, you got what's called a identity. I know it says consistent there. That's just a little mistake. It's going to be identity. And there you have infinite many solutions. Every solution along the line is a solution. And then the third one, this is if you have two parallel lines, you actually have no solution. They will never intersect. We call this inconsistent. So we're going to look at different ways of solving these, and we're going to start out with linear equations. So if we have 2x minus 3y equals -1, x plus y equals 7, one way to find a solution is to plot the points and graph them. Okay, so what we can do for these is to solve for both for y. So x plus y would be y equals 7 minus x. And then the other one, do this in a couple steps. You have -3y equals a -1 minus 2x. So then y equals 1/3 plus 2/3 x. And so we can plot them. First one I'm going to plot in blue, 7 minus x. So 7 is where it crosses, and then it goes down 1 as you go to the right one. This is your line. Then the other one I'll plot in red. Now, this crosses at 1/3. The two y-intercept. And then for every, it'll go up 2 every time it goes over 3. So 1, 2, 3. So at 3, it goes up to 2 and 1/3. And so then we go over another 3. 1, 2, 3. And it goes up to 4 and 1/3. So this is your line. And we can see the solution here is going to be at 4, 3. And you can see what graphing, when you're graphing it by hand, if you plot it just right, then, there's no discrepancies. This one does come out to be whole numbers, which is nice. But when they don't come out to be whole numbers, sometimes there's some margin of error in a sense of how we plot them. The next one I'm actually going to plot on the calculator. So both of these, again, we got to solve for y. So the first one is y equals -3x minus 10. And the next one, 2y equals -2x minus 16. So y equals -x minus 8. So you have to have them in your y equals. We go negative 3x minus 10. Then we can plot the exact same one, negative x minus 8. And we can do zoom standard. Should fall right in the right line. And so we get one coming down. Both of them have a negative slope and they're both coming down. They seem to cross at 1, 2, 3, 5, 6, 7, 8. And maybe 1, 8 maybe. 1, 7. So it's a little bit harder to tell on here. So what we can do is we can do second calc, intersect. Then it'll ask for the first curve. So you just pick the first curve. Ask for the second curve, you hit enter again, then enter a third time. Okay, -1, -7. So that's second calc, intersect. Then you pick each curve. Pick each curve. And your solution is -1, -7. So be down here. And this one crosses around here. And then this one crosses farther over. Estimate how it's going. That's where they cross each other. All right. So graphing is one way of doing it. And then we got a couple algebra methods of doing it. First one is substitution. And substitution is usually the go-to method when solving equations because it's just the easiest one to follow. It works best if you have a variable that's by itself, like this x, then we can just solve for the variable. Okay, so that's the first step, is solve for a variable. Doesn't matter which one, it could be x or y, but we'll solve one of the equations for a variable. We'll have x equals 3 minus 6y. And then we insert that equation into the other equation. We insert 3 minus 6y into x in the other equation. This gets rid of the x, and we have now one equation, one variable, and once we find that variable, then we can find x. So now we just distribute here, 21 minus 42y minus 4y equals -0.5. Subtract 21, and these we can put together. So we have -46y equals -46. So when you divide by -46, you get y equals 1. Then we can plug y back in just to get x. X is 3 minus 6 times 1. It's going to be 3 minus 6, which is -3. So your solution is -3, 1. So good step would be solve remaining equation for the variable. Then insert that value into your first equation to find the other variable. Again, we did x first. This one, we see y by itself, so we'll do y first. So y will equal negative ax minus 14. We'll insert that into y in our first equation. And we'll distribute negative 40x minus 70. And then this will be negative 44x. This is going to be 110. And then divide by x, or divide by negative 44, so we get negative 110 over 44. It's going to be negative 55 over 22. Now, since we're doing a lot of graphing, we can actually find a number for that, especially if it's going to be a nice number. So negative 55 divided by 22, get negative 2.5. Easy number to plug in and solve. And so now we want to find y. So negative 8 times negative 2.5 minus 14 times negative 8. And minus 14 will give you 6. And so your solution is negative 2.56. The other way, and this works when you have things that can easily line up, but the other way is the elimination method. So the main step here is to find numbers to multiply each equation so a variable cancels when added. And you look for the easiest way possible. Here we see we could multiply the top one by 2 and the bottom one by 3, and your x's will cancel. Or you can multiply the top one by 5 and the bottom one by 4, and your y's will cancel. Doesn't matter which one. Both of those would be kind of easy. I would assume, though, multiplying the top by 2, bottom by 3 is be the easiest one. So when we do that, we get 6x plus 8y equals 14, and negative 6x minus 15y equals 0. When you add these, your x's cancel out. 6x minus 6x is 0. So you get 0 minus 7y equals 14. And divide by negative 7, and you get y equals negative 2. Now that we have that, we can go back to our original equations. Pick one of them, whichever is easiest, which I'm going to say the easiest one is negative 2x minus 5y equals 0, and that's because of that 0. And you insert your y. So negative 2x minus 5 times negative 2 equals 0. The negative 2x plus 10 equals 0. So we get 2x equals 10, so x equals 5. So your solution is 5, negative 2. All right. Next one. Now, I've seen many books tell you to multiply it so you don't have decimals. I'm going to tell you this. Multiply it the easiest way that you can get something to cancel. But if you have a couple of decimals, it's not that much of an issue. So in this case, if I multiply the top one by 5, my y's will cancel. I don't have to multiply the bottom by anything then. So then I have 0.5x plus y equals, and then 5 times 0.64 is 3.2. Right, and then at the bottom, I have just what I have. So now I can add these. I get 3.5x. Y's cancel, so you get 0. And here you get 5.6. So it's not too bad to handle some of these decimals, especially since we're just adding for the most part. So now we have 3.5x equals 5.6. So x is 5.6 over 3.5. You get 1.6. So that's your x. So now we gotta find y. I think the easiest one is to use 3x minus y equals 2.4. Actually, before I insert 1.6, I'm going to solve this for y. So add y to both sides. And you get 3x equals 2.4 plus y. Then subtract the 2.4, you get y equals 3x minus 2.4. Now we can plug in the 1.6. So 0.6 times 3 minus 2.4 gives you 2.4. So your solution here is 1.6, 2.4. Right. Let's do some systems that come from actual applications. That's usually how it ends up being. First question, a total of 484 students took either algebra or chemistry last quarter. If there were 52 more algebra students than chemistry students, find the number of students taking each course. I'm assuming these courses don't allow you to take them both at the same time. Maybe they both are offered at the same time. Right, so total students. Right, first thing we gotta do here is we gotta let variables be what they are. You can use any letter you want. I'm gonna use X for algebra and Y for chemistry. But if you want to use A for algebra and C for chemistry, that's fine too. And then the total is 484, so X algebra students plus Y chemistry students have to equal a total of 484. That's your first equation. Now the next one's harder to get. If there were 52 more algebra students than chemistry students, right? So that means the algebra students, which is X, has to equal the chemistry students, which is Y, plus 52, since there's 52 more. Now this type of system, you would think that substitution would be an easy one to do, and it is. You can plug y plus 52 right in there for x. You can also adjust this kind of easily, so you get x minus y equals 52. That makes elimination just as simple. Okay, but I am going to do substitution. So I'll have y plus 52 plus y equals 484. Add the y's together, you get 2y, and then subtract the 52. So you get 34, 32. So y would equal 216. And then x is going to be the other half of that, or other part of that. So x is going to be 216 plus 52, and you'll get 268. So we have 268 algebra students and 216 chemistry students. Okay. Next one, peanuts costing $3.25 a pound and candy corn costing $2.20 a pound are mixed to make 50 pounds of a mixture that costs $2.62 a pound. How many pounds of each are used? Right, so I'll do this. P for peanuts, pounds of peanuts. and C for candy corn. Right, so P pounds times 3.25 a pound is how much you'll have in peanuts, plus C times 2.20 a pound is how much you'll have in cost of candy corn. And that has to equal 50 pounds of a mixture that costs $2.62 per pound. So we'll do 50 pounds times 2.62, and that's the cost of the total amount of pounds. That's actually the harder equation to get. The other equation is P pounds of candy corn plus C pounds of candy corn. I'm sorry, P pounds of peanuts plus C pounds of candy corn has to equal 50 pounds. Right. So for this one, again, I'll probably do substitution. Solve this for P. So P equals 50 minus C. Then substitute that in for P. So 50 minus C times 3.25 plus C times 220 equals, and then 50 times 2.6 is 131. So we got to distribute this. So 50 times 3.25 is 162.50 minus 3.25C plus 2.20C equals 131. So we're going to subtract the C's. So we'll get a negative value minus, let's see, 1.05C equals 131. Subtract over the 162.5, so we actually have a negative value on that side as well. 131 minus the 162.5 is a negative 31.5. And then those minus sides cancel out, so we just got to divide by 1.05. C is 31.5 over 1.05. Got the negative sign. And divide by 5. We get 30. We have 30 pounds candy corn. And so if there's 30 pounds candy corn, there's 20 pounds peanuts. We can get that by plugging this into this equation. Some of these, the easier equation though, is pretty simple to just sometimes look at and know. Next one, a riverboat travels 48 miles downstream in 3 hours, and then 52 miles upstream in 4 hours. Find the speed of the boat, speed of the stream. The way this works, this is the same thing when we have planes that are traveling with air wind speed, is that your velocity going downstream, we use v for velocity, is going to be equal to the boat speed. I'm going to use b for boat speed plus the water speed, river speed. I'll use r for river speed. Okay, so b is boat speed. And r is river speed. Okay. When you're going downstream, they add together. Your river speed helps the boat go down, as well as the speed of the boat, which is based on the motor. Okay. Going upstream, the river speed acts against it, and so it's the boat speed minus the river speed. Okay. Think about it, if the river speed is less than the boat speed, the boat still makes it up the stream, just lower velocity. If the river speed is higher than the boat speed, which would happen if you turn off the engine of the boat, then the river would take the boat back down in the stream. Okay. Now, when it comes to your velocity is distance over time. Okay. And we have time 3 hours for going downstream, 4 hours for going upstream. So the way we look at this, if we actually multiply the t over, your distance is your time times your velocity. So downstream, your velocity is b plus r, and your time is 3 hours. And you go a total of 48 miles. And for your upstream, your time is 4 hours, your speed is b minus r, and you're going 52 miles. So we can do a little bit of simplifying. Divide the 3 over, you get b plus r equals 16. Divide the 4 over, you get b minus r equals 13. This is one that sets itself up to just being using the elimination method. If we add down, we get 2b equaling 29. So b equals 14 and a half. So the boat speed is 14 and a half. Miles per hour. And then the river speed, we can find that by using any of these equations. You can use the top one. So 14.5 plus your river speed equals 16. Subtract over, you get river speed equals 1.5 miles per hour. River speed is 1.5 miles. Right. So this boat, if it's going up the river, will make it to where it goes, but it's going to go a little bit slower. Right. The last application question here is break-even type of a problem. Break-even being when your income and your cost equal out and up equaling 0. Income being revenue. So here revenue is 15.5x. So 15.5x minus your cost, which is going to be 12x plus 1680. And that has to equal 0. Or when your revenue and your costs equal each other, so if we add that over to the other side, we get 15.5x equaling 12x plus 1680. Then we can subtract over the 12x, and we get 3.5x equals 1680. So x equals 1680 over 3.5. And we get 480. So if x is like the number of units of something being sold, you sell 480 and your cost and your revenue equal itself out. All right, so next video we'll look at 8.2 and we're going to look at variables in when we have 3 variables and we need 3 equations. All right, I'll see you then.